Welcome back, everyone. Thanks for still staying in this video stream. We are going on with our next session where we're going to discuss the next steps of deploying a model or putting your whole process of building machine learning models into a pipeline. Now, if we think back about just classic programming, we know when programming we solve a specific problem by writing an algorithm, we put data into it and we get an answer. We have our business logic built within that block. But now we have the issue that we don't, what happens actually when we don't know what the algorithm looks like and what is the business logic to get to that answer. Is there a bird in a picture, or what's the chance we will sell 50% more items than before? Well, that's where, of course, machine learning helps us. Where in machine learning, we will switch the algorithm and the answer from sides. So we will give answers and data into an algorithm, and it will generate, we will train the data and it will generate an algorithm. Now, our algorithm, well, we could call it our model. Now, what we're doing is letting the computer build a model to describe that data combined with his answers. Now, once we have that data, that model, we can use that model and add data to it to generate our predictions. Now, if we go back to our example of tailwind traders. Now, as we've seen before, Tailwind Traders has a nice website. Okay. And when we upload a picture, it will show us similar products. Now, let us upload a picture of a wrench. We open it, and actually that one works quite well. We see where it's stored in the shop, and so on. Now let's look into another one. We will take a claw hammer and see how that links to a good product. So now we get a basic wrench, and that's not what we really expected. So what we're going to do is we're going to change some elements within our training file or training script, and then we will just, as we usually do with code, we will add it into our Git repository, commit it with a nice message. So update training models, and then we will push it to our repository or remote repository, and that's it. Let's see later on what happens behind it. Now, let's talk about the work that happens when creating a predictive model. Usually there's some discovery, transformation, and preparations. Some building of a model and training using that data and evaluation of the suitability of that model. So we have our data that we need to build and train on it, and then we will evaluate. So to get a highly iterative experimental process, that might mean going back to the drawing board many times over a long period of time. So when it's time to actually deploy a model, it's often similar to the way we used to do in software. Package it up and let the developers or operations team deploy it somehow. Now, the creation process often happens on a data scientist machine or shared hardware for intensive training, maybe a supercomputer. Actually, we have supercomputers on Azure that we can perfectly deploy. So, and then deployment quite happens often passing by USB drives or even by mail. What is sadly enough still done, but let's see how there's a better way of doing this. Now, let's contrast this to the good DevOps process where we plan, we do development and then test and release. Then we go to a production environment where monitoring and we learn new things out of how things are not working well or are working well. We get feedback from our customers or from our business. So this is actually the DevOps process for software development. But could we use this also within machine learning? Now, let's go to the Microsoft definition of DevOps. DevOps is the union of people, process, and products to enable continuous delivery of value to our end users. The most important word here is value. DevOps is not about keeping codes together or bug fixing. It's about continuous delivering new or updated value. So if you have a predictive model and you can make that model better, well, that's absolutely valuable. So this definition doesn't exclude ML. So let's look at a product that can help you with that. So you may have heard already about Azure pipelines, but it's important to note that these are different products. We'll talk about the difference in a minute, but a high-level machine learning pipeline is good for training workflows, and Azure pipelines are good for orchestration. So they have two different focuses. Now, Azure Machine Learning Service is a set of services for helping your MLOps or DevOps for machine learning efforts. You can get to it by going to ml.azure.com, where we have our portal, and you find all the things. Let's drill into a few of the things that might help you to manage. So, as discussed before, we have a list of all different items. We have our data sets, we have our experiments, we have our pipelines, we have our models, we have our endpoints for real-time endpoints and for deploying models. Then we have pipeline endpoints for training our data. And then, of course, we have managing our compute, our environments, and our data stores. Now, we're going to focus for the moment on pipelines. So pipelines are workflows for training our model. And we want to build one so we can have a repeatable way to build our predictive model. Now, what's the difference and why do we need both? So, machine learning pipelines are designed for specific machine learning specific workflows. So that we can do unattended runs that might take very long because our training data has just been taking, it's just a while. So we have unattended runs. We want to reuse certain parts of our code. And of course, we want to keep tracking of how are our models doing when we change specific parameters within our scripts. Now, if we compare it to Azure pipelines, well, with Azure pipelines is for orchestration and mostly continuous delivery and integration. So what we have there, it's a perfect place to have gates. It's for quality checks and balances. We have integration with other applications, artifacts, and dependencies. And then, of course, we also have triggers. So we want to have, for example, every day automatically an automatic release with latest data or so on. So this is all possible with Azure pipelines. Now, we're going to focus on the moment, as we said before, on pipelines. And pipelines are workflows for training our model. And we want to build one so we can have a repeatable way to build our predictive model. So, okay. We'll go now in a demo again. We're going to alter some things and we'll see how we can build that machine learning pipeline. So we're talking here now about the ML pipeline, not about the Azure pipeline. Let's have a look. Okay, so we go to our Jupyter notebook where we're actually setting up our machine learning pipeline. We are importing certain packages just as we normally do. We set up certain variables about storage names, and then we need to register our data store. That's the first step. But before that, of course, we need to connect to our workspace. So once we've done that, we can use the same config again and again. Then we have our data source. Now, as usual, we need to link a specific compute resource to it. So here in this case, we set up what kind of virtual machine we want. And now we can define our pipeline. So again, also our pipeline needs specific variables, like which compute will it use, where is the data stored, give it a name, of course, and then we can add the different steps. So our first step is the data processing, and for that we call a specific Python script. We don't need to specifically call another notebook. We can just have a partly Python script. Then we do our training. Again, there we call a specific Python script, and we can add some arguments that we will push to our training script, as we have changed in the first demo. Once that is done, we need to register the model that has been created. And again, that's a specific Python script that we can actually reuse, and most of the time these scripts will almost stay the same. And then we publish it, and you see we've created different pipeline steps that can be reused, and we have a reference to our model. Now, if we run this, we get a nice overview of all the different steps, visualize, and when we click here on the link, we go straight back to our Azure Machine Learning workspace. Now give it a little time to load, and we will see also what we can what interesting information that we can find there. So what we have here now is we have the 3 different steps, and we see that they are completed, how long it took, and what kind of step it was. If we click then on the run itself, we have all the details of the accuracy of our model and which version of our model was doing better. And of course also the parameters that we've configured. In the logs, we can look at everything in detail that has been executed for each run. Then if we go to back to our experiment, where we still have a nice overview of the full time span of running the model and so onwards. So this is actually a really nice location. Although everything is done in code, your automatic pipeline generation is done within your machine learning workspace, but you can look into detail still what happens, and if something goes wrong, you can look into your logs to see actually what went wrong. Now, so what we've built was the machine learning pipeline. We did data preparation, we did training the data, and then our last step was registering the model. In the meanwhile, we connected to our data set, and we also used our compute. So we've already had quite an amount of elements out of the list that we discussed before. But now let's talk a little bit about working in team, because why would you work alone? It's nicely to work together, and sharing knowledge just increases your own knowledge. Now, some of the good DevOps practices we use in software development can exactly be copied to machine learning projects. And let's have a little talk about that. Now, Jupyter Notebooks files, they contain not just the input, but also the output. And this can be confusing and actually makes files difficult to merge. So we only want the input cells, the code that gets run. So we also want to define everything in our pipeline, which we are doing, as well as infrastructure like the compute, and any dependencies like your Python dependencies, libraries, and so on. And maybe we also want to add some data, not everything, but just enough to try out some proof of concepts. Why is that the case? Well, we want our experiments to be rerunnable. So if your data changes on your source and we didn't version our data, well, the quality of your model might be different because your data changed. AI stands or falls on your data. Now, as known, shared data source means every data scientist is training against the same data training, and that the training data is also being used to produce those models. So, except your training, I'm going a bit over. Now, this is actually called continuous integration. So, what we want to know is that our code has changed. Every time a code, you're changing a Python script, it needs to trigger something. Refreshing then executes our Azure Machine Learning pipeline, and if we change the way we're training, we also want to check the code quality. Like, is it exactly how we wanted it, to do some unit testing and so on. And then we can also add PR processing or pull request processing to ensure that that there's someone, for example, that checks if your code is actually how we wanted it. So it's some kind of validation between data scientists or developers to see if everything is through the standards of the organization. If you want to get to know more information specifically about Azure DevOps, then for sure go to this URL. Now, the important point is that all code and software, that the quality of the code matters even if it's not what you're used to writing. And that counts also for data science. So with this point in mind, let's look also at the builds definition, which is the last part. How are we going to deploy it automatically? Let's look into another demo and see how we can fix this. Now we go to Azure DevOps, and where we have on the sideline we have pipelines and we have our builds. And I'm sorry I forgot. So with all of these things in mind, now let's look how these pipelines can be built. So how can the full process be done with the triggers and so onwards. Sorry. Okay, so for that we go to the Azure DevOps environment and we go to builds, and you see here I've done a commit, the one we did earlier during this session, and we see the different steps that it got executed, from preparing the job to initializing an environment to run the code. And then we have here the recreate and submit pipeline. So we have actually here all the data that we've created within our pipeline script. As you might see here, we have the different steps. We have the data preparation, we have our model training, we have our model registration, and also our data reference to the specific data. And we submitted that pipeline and it received a specific run ID. Now, if we look to that pipeline set up within our Python script, again, we have it's actually the notebook that we looked at, but a cleaned up version where we only have the Python code, and we define our data store, we link our workspace to it, and then we have the specific pipeline parameters, the environment that we set up, where do we get the data from, and then we have the steps by itself. Here we have our data preparation, again, that calls another file. We have our training step, again, that calls another Python script, where we configure our variables as parameters. And then, of course, we have our registering the model, and then we publish our pipeline and we run it. So actually, once you have this file, you can easily reuse it also for other projects. Now, the next step that we could do is to build our pipeline itself, which is a YAML file, where we will say what needs to be executed and to generate some kind of package. And that package we will use in a later phase. So in this case, the most important task is a recreate and submit pipeline, where we are calling our Python setup, our Python file, the setup pipeline script. And from there onwards, we will go through the whole process. So within the logs of that recreate and submit pipeline, we also see again the link to our machine learning workspace. So let's give it some time to load. Okay, takes a little bit longer than usual. Okay, so what we have here is exactly as what we have done already in our notebook before. We have the view of how our pipeline is built and the different steps. We can click, for example, oh, strange doesn't work. We have our output, which is for this side is empty or logs, also because this is on pipeline level. Now, if we would go back to details, then we click, for example, our data preparation or our model training. Let's click on model training. We have, again, the charge of the loss and the accuracy of our model. And we also have all the tracked metrics, which variables did we set. And then here we have all the logs of what happened, just as we had within our when we run it through our Python notebook, Jupyter notebook. Now, if we go back to pipelines, back to our experiment, and we go to model registration. Model registration. And we look to our outputs. There you can see we can actually also download our model file. Now this is a binary file, so you can't actually see what's going on. And of course, what also is generated is a snapshot of all your Python scripts. So with this, you know exactly what has happened to build that specific model. So we produced in an automatic way now or a machine learning model, but we need to actually add another step to our machine learning pipeline. But we will not do that in our machine learning pipeline. We want to have a bit more control over deployment because we want to, for example, hold off specific models if the accuracy is maybe not good enough. Now, for that, we still haven't deployed anything. So we have a newly trained model. So now we're going to deploy it. So Azure Machine Learning Service has the ability to take a model and deploy it to Azure Container Instances or Azure Kubernetes system. But we are going to make use of it, but not directly through the UI here. We'll make use of continuous delivery. And let's also have a look through how that is done. So what happens with continuous delivery is that we're having a specific model that got registered. And then with the pipelines, with the Azure pipelines, we're going to deploy it to specific environments. Then we can run some tests on it, on pre-prod environments and so on. And the most important part is that we have full control over what is going on. And we can roll out some techniques that we can use for also the rest of our software. So don't just put models in production. You wouldn't do it with software. Why would you actually even do it with machine learning models, which are making decisions for your business? So for that, the deployments to environments, we will have a look at Azure Pipeline releases. Now let's look into a demo also here and see how that works. So within the DevOps environment, you have pipelines, and before we looked at build, but now we want to look at releases. Now I've already configured a release, but we'll look into a little bit deeper. So you see when we click on it, we have a specific artifact that is generated from our build with all the different steps. And also here, we're looking at the deployment. We will see how it's configuring an Azure Kubernetes system, setting up everything and copy it to copy the model to it and make it production ready. So now let's have a look how we can edit it. We'll start with just removing this artifact, and we'll create a new one so we can see how that is done. So we'll just delete this one. Now let's add an artifact from a build. We choose for Azure ML pipeline, we choose our endpoint, and then the model name that we've configured. So it will always get the same model names, your pipelines, but a later version. Now we have here continuous deployment trigger. If you want to automatically deploy, then you need to switch it on. It means with every build, it will automatically deploy your model. Now within our release, we have a task Azure ML model deploy, where we can configure if we want to make use of Azure Container Instance or an Azure Kubernetes service. And then our pipeline is actually built and we're ready for a full deployment. Now we can also set up pre-deployment conditions. What does that mean? We can say certain people need to approve before it goes into production, for example, or we could define certain gates that things need to be validated before it works. So in the beginning of the session, we changed some variables to our training script, and we just uploaded a picture of a hammer now, and we get back our hammer. Now let's upload our claw hammer and see what we get returned now. If it's still a range, no. Well, actually now we have our hammer, and that's what we wanted. Now let's look at, so we looked at the release pipelines. My slides don't want to work. Okay, so what have we created? We have a pipeline for training, which is an Azure machine learning pipeline. We have our data preparation, our training, and our model registration. So every time we have a new model, we kick off a deployment pipeline in Azure DevOps, and that deploys then to your Azure Container Instance or Kubernetes, where we can do some tests, and if it's going well, for example, we can go to Azure Kubernetes system. Or depending on your use case, maybe you can stay with Azure Container Instances, but that's up to you. So just like the rest of our software, we don't need to put our model in production and just leave it there, assuming it will always work. So we need a retraining strategy, because either periodically or when the data is different enough in production, we might not get the results that we want. So Azure Machine Learning Service has a solution for that, and that's just by rerunning your script on the new data, for example, the retraining process. So we do retraining, and then of course our model gets republished. So when we train, we can do so from a known training data set, and when we ultimately deploy to production, we can store the inputs into another data set or inference data set. So that way we also always have a copy of it. So periodically, Azure Machine Learning Services will let us compare these two data sets, looking for data drift. So if we if what we're seeing in production drifts too much from our trained model, we can kick off a new training process to produce a model, and this can all be done automatically. So with this, we have our full pipeline. But of course, as discussed before, if we change our code, we also want to change our training pipeline, and that's all the different steps that we looked in during this session. Okay, so importantly, this was just an example. We're deploying our model to containers, but maybe we want to embed the models into our software. Or we're not using AML at all, maybe we're using different cognitive services, and they all have great APIs that Azure Pipeline can talk to. Ultimately, Azure Pipelines can orchestrate anything, so whatever set of tools you are using, you can use it to manage your training. In summary, we have a lot of great tools within our Azure Machine Learning services, specific elements to keep track of our codes, to share data sources, to build pipelines for machine learning, for training our data model, and for deploying to a specific environment. We have a retraining strategy in case our data changes or we want to do updates into our training data set. And then of course we have DevOps on itself, which is a very good practice for everyone for delivering what is needed. With this, we close this session for deployment of pipelines. The next session will go a little bit more in depth, talking about automated machine learning. But let's have a small break now and then we continue.